In this tutorial, I'm going to show how to use the calculation block. The calculation block allows you to create new variables whose value depends on other variables. So here we have a rat race circuit. It's 4 ports, 4 transmission lines, and we have an A port and a B port. We have a sum port that is the sum of the A and the B port, and we have a difference port. It's the difference of the A and the B port. It's generally made up of 3 90-degree lines that's at the 70.71 ohm impedance and one 270-degree line. So if we take a look at the performance of this circuit, we can have the match, the sum, and the difference. So we have the S21 plus the S32, and we have the for the sum, and then for the difference we have the S41 and the S34. So if I hit refresh, I get my match, sum, and difference plotted, and then the sum port is 3 dB because we're summing the power for 3 ports, and then the difference and the match are both nulls at the 1 GHz. So that's what we hope to see when we run our optimizer. So I'm going to go ahead and spoil these values. Turn on my optimizers and let this run. Now, the problem is we have a number of values that will sort of work for the impedance and the electrical length. So if I update this, we end up with the 90 ohms impedance that it thinks it should be, and the electrical lengths are wrong. The problem is, in reality, what we really want is this to be 3 times longer than that. When we're optimizing, whether it be setting up our figure of merits in an intelligent manner, or setting up our bounds for our variables in an intelligent manner, we want to put more intelligence into the optimizer as much as we can. So what I'm going to do is I'm going to put in a calculation block that you can find in the Mason library. I actually already have a calculation block in here, so I'm going to turn off these variables, and instead I'm going to have a calculation block where I'm going to say my Z2 variable for this transmission line is equal to Z1, and my electrical length, theta 2, is going to be equal to 3 times theta. And that's just something that we know about the rat race circuit, so we're going to tell Mason that. So now when we run Mason, even in the genetic optimizer, it's able to get a good solution. And so now if we take a look at this, we have the nice plot. We have values that are reasonably close to what we would hope for, the 70.7 and the 90 ohms.